everybody, how are you? I sure you're doing very well. Today inshallah we'll continue with lesson number 3, forces. So let us start. Guys, force and motion actually are related, and a British scientist called Sir Isaac Newton explained this relationship between force and motion with 3 laws of motion. So we have inshallah today we'll discuss about Newton's first law, Newton's second law, and Newton's third law of motion. So let's start with Newton's first law of motion. As we said, Isaac Newton described 3 laws of motion that explain the relationship between force and motion. Newton's first law describes the motion of an object that has a net force of 0 Newton acting on it. What do you mean by that, guys? The law states, this law, guys, the first law states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and direction, without any change in speed and direction, unless it experiences an unbalanced force. And we may remember that we said unbalanced force means that the forces that will act on this object are not equal. So guys, actually Newton's first law is also called the law of inertia. Inertia is what? Inertia is the tendency of all objects to resist any change in motion. So all objects, guys, will not experience any change in their direction or in their speed unless certain force will act on them. Okay, so the law of inertia explains why a chair will not slide across the floor unless a force pushes the chair, and why a golf ball will not leave the tee until a force pushes or act on it. Okay, so according to that, guys, let us try to answer the following question. So the question is, use Newton's first law to explain why the dishes remain in place when the magician pulls the cloth out from under them, as you can see here, guys. So guys, inertia causes the place to remain in place. Why? Because the tablecloth didn't exert a force on the place great enough to make the place move. So as we said, all objects, according to inertial law or Newton's first law, all objects have the tendency to resist any change in their motion unless enough force acts on them. Okay, now guys, let us move to Newton's second law of motion. So what is Newton's second law of motion? Newton's second law states that the acceleration of an object depends on the mass of the object and the amount of force applied. So guys, whenever you want to calculate, for example, force for a certain object, you're gonna use the following formula. Force is equal to, according to Newton's second law, force is equal to the mass of this object times what? Times acceleration. So force here, you will represent it with the capital letter F, equal to what? To the mass of this object, and here we're using the small letter m and the small letter a to represent what? To represent acceleration. So force is equal to mass times acceleration. Okay, so guys, let us now try to answer this question using the following formula, or by applying Newton's second law of motion. The question says, these players train by pushing a massive object. If the players push with a force of 150 Newton and the object has a mass of 75 kilogram. What is the object's acceleration? Okay, so guys, here we have two known values. We have the force F is equal to 150 Newton, and we have the mass of this object, which is equal to 75 kilograms. So simply we're gonna first of all, okay, we will write the equation that we will use it in our calculation. As we said, Newton's second law states that force is equal to what? To mass times, okay, so mass times what? Mass times acceleration. Okay, gonna use dot okay. Acceleration. Now we need to plot the known value. We have the force, which is equal to 115 Newton. 115 Newton equal what? Mass 75 kilogram. Okay. Times what? Times acceleration. And here we need to the unknown value is acceleration. What is the object's acceleration? We don't know the acceleration. Okay, we need to calculate it using this equation. So now guys, simple calculation to find out A. What you're gonna do, yes, exactly, we'll divide this value by 75 and we'll do the same for the other side. Okay, so here A is equal to, small a is equal to 150 Newton, and don't forget guys to write the units of all these measurements. Using units is so important in our calculation. So 150 Newton divided by what? Divided, well, maybe I'm gonna use this one, divided by 75 kilogram. Okay. So now A is equal to what? Again, small a is equal to what? 150 divided by 75 is equal to 2. So acceleration is equal to 2, and you may remember the unit of acceleration is meter per second square. Okay. Square. Whatever. Okay guys, so here's the answer guys for our first sample problem. I wish it's clear enough for you. Okay, let us use this color. Okay guys, so now to check our understanding, let us try to answer this question guys. Calculate. So for a more difficult training session, the mass to be pushed is increased to 160 kilogram. If the player still push with a force of 150 Newton, what is the acceleration of the object? Guys, please try to answer this question by yourself using the same formula that we used here, okay? And find out the answer of it, okay? So now guys, let us move to Newton's, but before moving to Newton's third law, let us see the application of Newton's second law. Okay, so Newton's second law on you. Have you ever been on a roller coaster? Did you feel like you weren't going to float out of your seat when you went over a big hill? Actually, when a roller coaster is going uphill, there are two important forces acting on you guys. The force of gravity that is pulling you downward, and the upward force exerted by the roller coaster seat. Okay, so once the roller coaster starts down the other side of the hill, it accelerates downward, and your seat doesn't support your full weight. Okay, so guys, another application of Newton's second law is, as you can see here, you can feel it when you are in the plane. Okay, so the airplane's path looks like a roller coaster hill. As the plane accelerates downward, what will happen? The passengers lose contact with the plane and fall toward Earth. This condition is called what? Free fall. Okay. So guys, now let us start with Newton's third law of motion. Newton's third law of motion states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first one. Okay, so in other words, guys, all forces act in pairs. All forces act in pairs. So action and reaction forces are present even when there is no motion. Let us consider the following example to understand the third law better, guys. Here, what do we have? The question is, the arrow below represents the action force exerted by the swimmer. Okay, so guys, here when a swimmer pushes off against a wall, as we can see here, what will happen? As we said, the wall pushes back against the swimmer. This is exactly what we said right here. So as we said, again, whenever an object exerts a force on a second object, the second object exerts an equal force, but it will be what? In the opposite direction. So here we have two objects. We have the swimmer, and we have what? We have the wall, okay, of the swimming pool. And now what will happen? As we say, the swimmer pushes off against a wall, so he's exerting a force in this direction. I mean to the left. Okay, so this object is exerting a force against another object, which is the wall. At the same time, as we said here, the wall will exert a force that is equal to the force exerted by this swimmer. Okay, but it will have the same value, it will have the same force, but it will be in the opposite direction. In opposite direction. So it will be, guys, this way. As we say, the force will be equal, so the length of the arrow should be the same. Okay, to indicate equal forces, we need to what? To have similar sizes of these arrows. Okay, so here we have an equal forces, but the force right here that is exerted by the wall against the swimmer will be in the opposite direction. Okay, so again, guys, as we said, all forces act in pairs. Okay, so if any object is exerting a force on another object, the second object will exert the same amount of force against this object, but it will be in the opposite direction. Okay, that's why we say that all forces act in pairs. There will be action and reaction. The action here is exerted by what? By the swimmer. The wall will what? Will take the reaction, or will exert the reaction. Okay, so action and reaction. Action by the swimmer and reaction by what? By the wall. Okay, so So guys, again here, label the action force and reaction force in the image. And below, as you can see, two arrows, they have the same length, which means that the forces are equal, but as we can see, they have opposite direction. Okay, so now guys, which one is the action, which one is the reaction? Exactly, this arrow represent the action and this one represent the reaction force. So here the ball is exerting a force against what? Against the ground, and then at the same time the ground will exert force against this ball. So this one will be the action, this one will be the reaction. So guys, the last thing that we need to add it here is, even though action and reaction forces are equal in size, their effects are different, and this inshallah we'll discuss it later on. Another thing guys, an object can have multiple forces acting on it at once, but when this happens, each force is part of a force pair. So for example, if we have this object guys, okay, multiple forces, as we said, can act on it. Okay, so if we have a force that is pushing like this way downward, at the same time we said that we will have another force, but this force will be acting on the opposite direction. Okay, this way. So this is our first force pair. At the same time, if we have another force that is acting this way, like if you're pushing the box this way, at the same time guys, we will have another force that will be acting in the opposite direction. Okay, the same one, for example, but in the opposite direction. So guys, as we can see here, we have multiple forces, but each actually are acting as we said in pairs. So this one, for example, our first pair, or our first force pair that has this color, the orange color. Okay, the second force pair that is acting downward and upward. Okay, so guys, that's all for today. Thank you, and see you inshallah tomorrow.